Alright, today we're solving the 2010 AMC 10A problem 16. Non-degenerate triangle ABC has integer side lengths. BD is an angle bisector. AD equals 3 and DC equals 8. What is the smallest possible value of the perimeter? So let's try to get like a pictorial so we can better understand what's going on. So let's just draw out the triangle. We have A, B, and C. We know that maybe D is on AC, and this is an angle bisector. AD equals 3, and DC equals 8, and we know that this is just this length, this is just this length. Alright, superb. What can we do from here? Well, what do we know about angle bisectors? We know that if an angle is bisected, then we can apply the angle bisector theorem. So imagine this is A, B, C, and D. We know that A to C is proportional to B to D. That's what the angle bisector theorem states. We also know that A to B is proportional to C to D. And why is that? Well, left to right, top to bottom, top to bottom. That is why they're corresponding sides. So what can we really do with this information? Well, we notice that we can kind of use the pictorial or the image I drew here to apply that to this problem. So we can practically call BC A, and we can practically call AB B, and then we call this side C and D. And this is how the graph would work. And if you were to kind of, reflect the figure across this line, this is what reflect the figure across this line. This is what it would look like, right? And it'll make a lot more sense. And so now you see that D to C is proportional B to A. So 3 to 8 is equal to B to A, right? D to C proportional B to A. And yeah, we just basically took the reciprocals, and this is the same thing. Right to left, left to right, X, Y, Z. And so now you see that 3A equals 8B. And you see that B equals 3/8 of A. Okay. Well, why did I choose this and not A equals 8/3 of B? Well, that's because I want there to be more restrictions, because a multiple of 8 gives a lot more restrictions, and yeah, it's very, very helpful. So let's just try plugging values for A. Let's try A equals 1, or let's try A equals 8. We have to be a multiple 8 because we have integer side lengths that we stated earlier in the problem. Integer side lengths, right? This is important. And so we know that A has to be a multiple 8, so let's just do AB. A could be 8. That means that B would be 3, and if you plug that in using a triangle inequality, which basically states that if you have a triangle like this, ABC with lengths A plus B has to be greater than C. A plus C has to be greater than B. C plus B has to be greater than A, and this is basically what it states. So, if A were 8 and B were 3, then what would happen from there? If A were 8, then we would simply have the triangle inequality be flawed, because 8 plus 3 is equal to 11, not greater than 11. Therefore, this won't work, and we have to try another multiple of 8. How about 16? Well, if we try 16, then that means that B will be 6. And if you think about this, 6 and 16, 16 plus 6 is 22, which is greater than 11. 16 plus 11 is greater than 6. And then 6 plus 11 is greater than 16, or 17 is greater than 16. So therefore, we satisfy the triangle inequality. And this is the second smallest, as this one didn't work. Therefore, we sum up all the sides. We have 6 plus 16 plus 8 plus 3. And we're going to get the answer of 33, or that is answer choice. Let me get my red. B. We're done.